So hey everyone, welcome to today's class. I think in my entire course, this is the only theoretical lecture that's going to be there. Because I mean to do this in practical would take a lot of time. Plus it's a little bit complex to do it practically, and it's totally not required for the solutions I take to associate kind of exams. So let's get started about learning about this particular service called as AWS Storage Gateway. So AWS Storage Gateway, it's a hybrid cloud storage service. So it gives you on-premise access to virtually unlimited cloud storage. So it's a hybrid cloud storage in the sense that it can be used to connect your existing cloud infrastructure as well as your on-premise infrastructure. And it allows your on-premise infrastructure to expand its storage to the cloud storage, which is, unlimited in nature because it's using Amazon S3 in the background. We will learn more about that in the subsequent slides. So these includes moving any kind of tape backups that you have to the cloud from your on-premise infrastructure as file shares, and you can also provide low latency access to your data in AWS for any kind of on-premise applications through the usage of a storage gateway. And you can do any kind of migration or archiving purposes. You could probably go ahead and use storage gateway for that too, because it uses S3 in the background. So in that way, we can also leverage the archival features of S3 like Glacier and Glacier Deep Archive and so on. So there are three types of gateways. The first type of gateway is called as a tape gateway, and then we have file gateway, and then we have volume gateway. And we are going to explore these in much more detail in the subsequent slides with nice diagrams that explain as to what these are. So we will start off with tape gateway. So with tape gateway, your on-premise infrastructure is over here, right? And then you have the tape library backed by Amazon S3, and then you have tape shelf, which is backed by S3 Glacier and Glacier Deep Archive, which is sitting in the AWS cloud, right? And you virtually download a connector or probably the gateway's AMI, and then you launch it onto an EC2 instance or your on-premise server, right? And then you establish a HTTPS connectivity to Amazon AWS, and then all of your data is encrypted at rest using server-side encryption in S3, and all the data that is transferred is encrypted in transit using HTTPS using SSL certificates, right? And then there is a concept called as virtual tapes, right? And then we will read more about this in detail in the subsequent slide. And then you have a concept called as tape drive, and then you have something called as a media changer. And then you mount all of these tapes as iSCSI virtual tape library volumes, and one storage gateway, or I would say one tape gateway, comes with one virtual tape library, right? It can be configured as one virtual tape library that spans your on-premise environment, and to extend it to the cloud, wherein you use durable storage services such as S3 and Glacier Deep Archive for archival purposes. Okay. So this is how tape gateway actually works in the background. So you mount your application or your backup application as iSCSI mounts to the gateway virtual machine, where you have two types of storage over there. One is called as a cache storage, and the other one is called as the upload buffer. And this upload buffer, all of the content that is sitting over here is being asynchronously backed up to Amazon S3 as virtual tapes. And this cache storage is there for you to provide that low latency access to your data, right? So you will have to connect this gateway virtual machine or this gateway VM to your storage area network, or SAN, or direct attached storage, or DAS, in your on-premise infrastructure. So you can have a data center A and a data center B, and then you launch two gateway VMs with those respective AMIs, and then you configure these disk volumes called as the cache storage and the upload buffer, and then you start asynchronously backing up your storage to Amazon S3 as virtual tapes. And then for archiving purposes, you can use Glacier or Glacier Deep Archive, which is called as virtual tape shelf, right? So virtual tape is like a physical tape cartridge. So therefore, each gateway can contain up to 1,500 tapes and up to total of 1 petabytes of storage at any point of time. The size of each virtual tape can be between 100 GB to 5 TB, right? And when you're using archival purposes, if you archive a tape in Glacier, you can retrieve the tape within 3 to 5 hours. But if you are doing it in Deep Archive, which is much more of an archival feature that they had brought out as one of the storage classes, then you can retrieve it typically within 12 hours or so. Right? And only after you retrieve, and only after you retrieve the data and make it available as a virtual tape or S3, then only you'll be able to access the data. So you can't directly access the data immediately when it's stored in Glacier or Glacier Deep Archive. Then we have the second type of gateway called as a file gateway. So it's a file interface or a file gateway that offers you a seamless way to connect to the cloud in order to store application data files and backup images as well as durable objects on S3. So it offers two types of protocol support. So it offers the SMB protocol and the NFS protocol. And it can also be used for on-premise applications as well as for EC2 resident applications that need access to that storage in S3. So once you are backed up using file gateway to S3, then EC2 resident applications, right? So any applications that you have running on EC2 can also get access to that storage data that you stored in S3 using an IAM role and so on, right? So this is how file gateway works. So you have to configure a file gateway using an EC2 image. And once the file gateway is activated, you can go ahead and configure your file share and associate it with an S3 bucket, right? And doing this makes the share accessible by clients either using the NFS or the SMB protocol. And then once your files are written to that file share, automatically they are asynchronously replicated to Amazon S3 with the path as the key in S3, right? And there is a one-to-one mapping between the files and objects, and it's being asynchronously updated to S3 in the background. And it's encrypted using server-side encryption with S3, and all the data transfer is done through HTTPS for security in transit, right? And then you can configure your own lifecycle policies in order to go ahead and transition it to Amazon S3 IA, which is infrequent access, and then archive it with Glacier. So one key point that you have to remember going into the exam for file gateway is that it uses the NFS and the SMB protocol similar to what we are using with EFS, because EFS is also Elastic File System, which we have studied in the EC2 section, and that also provides us with NFS and SMB protocol. But then storage gateway is something that you use as a hybrid cloud configuration to extend your on-premises storage, right? And now we are going to move on to the next one, which is called as a volume gateway. So the volume gateway provides local cache, or it provides full volume backup of your on-premise data to the cloud, right? It is very useful when you're using it for disaster recovery scenarios or any kind of migration scenarios. And the volume gateway runs in two modes, cached and the stored mode. So with cached volumes, the storage service stores the full volume in the S3 bucket asynchronously, and then the portion of the volume which is for low latency access data, the recently accessed data is always retained in the gateway's local cache for low latency access. So if you want the data access to be immediate, then you would configure yourself a cached volume gateway. And again, these data that is being backed up from storage gateway, which is of type volume gateway to S3, they are backed up as EBS snapshots. So with stored volume gateway, in contrast to cached volume gateway, with stored volume gateway, your entire data set is available locally on the gateway cache for very fast access. And at the same time, it maintains an asynchronous copy of your stored volume in an S3 bucket, right? And data written to the gateway cached volume can be asynchronously backed up as point-in-time EBS snapshots. With stored volumes also, such snapshots are required, because if you want to create a new EBS volume out of that snapshot and then mount it onto an EC2 instance, it will be very helpful, right? So into more depth with cached volume gateway. So cached volume gateway can range from 1 GB to 32 TB in size, and it is rounded to the nearest GB. And each gateway configured for cached volume can support up to 32 volumes, which means 32 volumes into 32 TB size each. The maximum is 1 petabyte, which is 1024 terabyte, right? So you can see in this diagram, you can see over here, we have a gateway virtual machine. So you can go through the Amazon docs in order to get the prerequisites of setting this up, and what are the necessary virtual machine configurations that you should have available, how many cores the CPU should be available with, how much of RAM you should have available, how much of disk storage you should have available. All those things are very necessary in order to set up this in your data center. And then again, like how we studied about the tape gateway, we do have a cache storage over here and an upload buffer. So your cache storage, when cached volume gateway, will have all of your recently accessed data for low latency access, and your upload buffer is going to asynchronously copy all of your data to Amazon S3 as volume storage and as EBS snapshots. So this volume storage also provides you with that low latency of access data, and you connect this gateway VM to your storage attached network or your direct attached storage in your data center, right? So again, the disks that you need to use for your cached volume gateway is that the first one is called as the cache storage over here. So this cache storage helps you in these with these features. So when your application writes data to your storage volumes, the gateway first stores the data on the cache storage. Then the gateway uploads that data to Amazon S3. So the cache storage, it acts as an on-premise durable storage for data that is waiting to be uploaded to Amazon S3. And it also provides you with that low latency access for your data for which is the recently accessed data for your on-premise applications, right? And the second one, which is called as the upload buffer. So this specific part of your gateway VM. So this upload buffer, it prepares all of your data to be uploaded to S3. And the gateway also stores the incoming data in the staging area, which is called as the upload buffer. And it uses a secure socket layer in order to connect to AWS, where it's stored as encrypted in S3 using server-side encryption. You can take incremental backups, which we already studied about, called as snapshots. And these point-in-time snapshots are also stored in S3 as EBS snapshots. And you can restore these EBS snapshots to become their own EBS volumes, which can be attached to EC2 instances. So now the second type of volume gateway is called as a stored volume gateway. So in contrast to cached volume gateway, where your recently accessed data is being cached on the gateway itself for low latency access, here your entire data set itself is being cached on the gateway. So only asynchronous backups are being done to S3 as EBS snapshots. So you don't have a specific storage over here which is providing low latency access, but at the same time, all of your data is going to reside in your gateway VM in the gateway cache itself, and then it's going to be asynchronously backed up to S3. So it's pretty similar to cached volume gateway. But when it comes to stored volume gateway, it can range only from 1 GB to 16 TB. With cached volume gateway, it ranged from 1 GB to 32 TB. But with stored volume gateway, it's only 1 GB to 16 TB, which means the maximum that you can store, which is 32 volumes for the gateway, is around 512 TB, which is half of cached volume gateway, right? And data written to these stored volumes is stored on your on-premise storage hardware, and then the data is asynchronously backed up to S3 as EBS snapshots. Okay, so going into the exam, you have to remember the two types of storage gateways: cached volume gateway and the stored volume gateway. And you should remember the differences between these two. Because if they are asking something along the lines of recently accessed data or low latency access to my data, which is my recently accessed data, then you can go with cached volume gateway. And anywhere they are mentioning that it can range from 1 GB to 32 TB, and total size is around 1 petabyte that I can store for a gateway, then you will have to mention cached volume gateway. But then if they are talking about something regarding stored volume gateways, which is backed up as EBS snapshots, and then you get access to all of your data set at the gateway cache itself, and it ranges from 1 GB to 16 TB, where the maximum size is only 512 TB, which is half of cached volume gateways. You can go with stored volume gateways. And wherever in the question they are mentioning something regarding the NFS or the SMB protocol, those are your keywords for choosing file gateway. And anywhere they are talking about archival or any kinds of virtual tapes that they have in their in their on-premise environment, which needs to be backed up as tapes to S3 using the virtual tape library or the virtual tape shelf, then you can go for tape gateway, right? So these are your key words that you have to look out for when you're working with storage gateway. Okay. So thanks a lot for attending this session, and please move on to the next lecture. So have a great day, guys. Thank you. Bye-bye.